Hello everyone, this is the third video on the SMO Senior mock paper. We'll be going through questions 11 to 15. By now you know the drill. If you want to look at the questions, you can refer to the mock paper itself in the link in the description below. So let's get straight into these 5 problems, where the difficulty will start to ramp up just a little, I think, at question 13 or 14. So for question 11, we have a pair of simultaneous equations. One of them involves absolute values, one of them does not. And we're asked to find what is the value of, well, essentially this requires us to find all the solutions, right? So as long as you find all the solutions, this will be fine. When you see a question on absolute values like this, you have a couple of options. One is to try to look for some very efficient way to do it. And the second is to just settle on splitting into all possible cases. In this situation here, I would say just split into all possible cases is perfectly fine, because there are only 4 cases depending on whether x and y are positive, x and y are negative, or one of each. So let's just check each of them. If xy is positive, then these are the simultaneous equations. So we can add 2 times of the first equation to the second equation, cancel it off to eliminate y, and we would get 5x equals to 100, and xy turned out to be both 20. This is certainly an actual solution because they are both more than 0, so we have found one solution. Next one, xy are both negative, then it gives you negative x minus y is 40, and the second equation never really changes. We can again now add 3 times of the first equation to the second equation. That gives me, I think I need to write this one down, negative 5y is 140, so y is negative 28, but this will give me a positive value of x. Okay, so does it give me a positive value of x? No, it gives me negative 12, right? So okay, so it does give me a valid solution. Now let's try one of each. If x is greater than 0 and y is less than 0, then x minus y is 40. 3x minus 2y is 20. If you take 2 times the first equation, subtract the second equation, you get negative x equals to 60, so that already doesn't work. X is negative 60, y is negative 100. This doesn't work since x is supposed to be positive. So one last case, if x is less than 0, y is greater than 0, y minus x becomes equal to 40. Same second equation again. And we can add 2 times of the first equation to the second, which would give us x equals to 100 and y is 140. Certainly that is also not correct, since x is supposed to be negative. So we only have 2 solutions at the top, and the 2 solutions here have values x is 20 and x is negative 12. So 20 plus 12 equals to 32 will be the final answer. Yeah, this is similar to one of the earlier questions I mentioned about the radicals ones. This is not a difficult question. It's a little tedious, but you can always put it off and come back to it at some point if you feel that you want to do something a bit more interesting while your brain is still alert. Come back to a question like this, don't forget that it existed, because it is eminently doable. Question 12. This is a functional equation. Let fx be a function such that f3x plus f4x equals to f5x for all real numbers x. We're given 3 values, f90, f160 and f250, and we're asked to determine the value of f120. For any functional equation like this, you have got two options. One is see if you can guess the function, and the other is see if you can get enough information about the function just to answer the question that they mentioned. I designed this problem such that both approaches would also work. If you want to solve this question by just guessing the function, it's not that difficult, because 3, 4, 5 is really suggestive of a 3, 4, 5 right triangle where 3 squared plus 4 squared is 5 squared. So you could guess something like fx is equal to x squared. But that's not true, right? Because, for example, if it were 90 squared, it should be 8100, not 405. However, if you look carefully, it is just a scaled down version of x squared for all of these. So this is 90 times 4.5. This is 160 times 8. This is 250 times 12.5. Basically, the second number is the original one scaled down by 20. So the function actually is fx is x squared over 20. Or rather, to be more precise, one possible function is fx equals to x squared over 20. If you recognize this, then you would be able to get the answer quite easily. And I deliberately made it such that it is possible to spot it. Its answer is 720, and it's not that obscure. The function is relatively clean. However, you might say that, how do we know this is the function? And the answer is, we don't know this is the only function that works, nor do we actually need to guess the function. So here's the alternative, which just involves putting in some values. You see 3, 4, 5 here, we want to get 120. The first thing I can put in is something like x equals to 30. So here's the alternative. Put in 30, you get f of 90, which we know, f of 120, which we want, is equal to f150, which we have no idea about. But f of 150 may not be too bad, because we see that it also is in the 3:5 ratio with the 250, and if we put in x equals to 50, we would get some information. So 150, 200, 250. We can also put in, to now find the thing about 200, which we know nothing about, and we can do that in conjunction with 160, which is in the ratio 4:5. So I put in x equals to 40, so that gives me 120, 160, and 200. So all of these are nice because they are either what we want, what we know, or in the case of something like f of 200 or f150 is something that appears twice, so we are still okay with that. Okay, so let's just rearrange all of these equations. So f of 90 is known. We are left with 150 and 120 are the ones which are unknown. In this case, we'll just leave it because f250 is the one that's known. It's 3125. And lastly, 160 is known. So f of 200 minus f120 is equal to f160, which is 1280. Yeah, so if you want to extract out f of 120 from this, we can take the middle equation and subtract off the other two to give us 2 times of f120. And subsequently divide that by 2 again. So this is 1440, and f of 120 would be equal to 720, which is the same answer as we got from our guess the function approach. So there we go. This is not too difficult to guess the values that are relevant, since 9 is 3 squared, 16 is 4 squared, and 25 is 5 squared. So you kind of feel that all of these are circulating around those same special values, which was really the point of the question as well. Okay, question 13 up next. You're given a degree 4 polynomial p of x and a bunch of remainders when divided by x minus 1, x minus 2, x minus 3, x minus 4, and x minus 5. This is nothing more than the remainder theorem. So really all it is giving us is a bunch of 5 values. P of 1, P of 2, 3, 4, and 5. And the values are going to correspond to those 5 that you see in a row. 2020, 2021, 2022, 2023, and back to 2022, which is a little bit odd at first glance. Because, well, why is this the case? Why wouldn't it continue? I suppose the answer to that is simply, it has no reason to continue, because if it did continue, it is suggesting that the polynomial is literally just x plus 2019. And that would not be a degree 4 polynomial. So if anything, we should be kind of grateful that it doesn't continue, so that we can at least try to figure out what else it is. But then again, there is no doubt that it does look very much like x plus 2019, and that's usually how we approach all these kinds of problems. We say that, well, it is actually like some other simple enough polynomial or function for the values 1, 2, 3, 4. Now this is not saying px is always x plus 2019, it just follows x plus 2019 at those values. If we subtract it over, here's where the nice thing occurs. We can say that the difference is 0, naturally, for 1, 2, 3, 4. And that in turn implies that this is going to have roots 1, 2, 3, 4. And px minus x plus 2019 is still going to be degree 4. Because it was degree 4 before you subtracted off x plus 2019, it will still be degree 4. So what does this tell us? Simply put, it tells us that we can factorize it by our factor theorem, specifically enough. It is going to have the factors x minus 1, x minus 2, x minus 3, x minus 4. All of these must be factors. And you have got 4 factors of a degree 4. So there's no space for any other factors except for a constant. So I'll call that C. Now you run out of space because that's already degree 4. Well, how do we find out the constant? That's always where the extra inconsistent value comes in, which in this case is if you put in x equals to 5. Put in x equals to 5, you get p of 5 minus 2024. So negative 2 equals to c times 4 times 3 times 2 times 1, so 24. And c is negative 1 over 12. So lastly, we are supposed to find the remainder when px is divided by x minus 6, and that is simply p of 6. So once we have found out everything about what the polynomial is, this is just a substitution directly. I put in 6 plus 2019, for the x plus 2019, and then minus 1 over 12, 6 minus 1, 6 minus 2, 6 minus 3, 6 minus 4. So this behind 5 times 4 times 3 times 2 divided by 12 is 10. So you have 2025 minus 10, and the answer is 2015. Alright, question 14. Now, to be honest, when I said question 14, it was meant to be a trigonometric problem. And then shortly after that, I realized there was a much simpler solution. So I'm going to go with the much simpler solution here. Let's mark out the pair of right angles which are important enough here. We can also note that 108 to 144 is in a 3:4 ratio. So it's a 3-4-5 triangle, and this hypotenuse AD will be 180. So I'll put that in first. Now, whenever you have a right angle on a line, that's quite significant because it means that the two other angles also sum to 90 degrees. And very often that's useful in giving similar triangles, because for this specific question, you've got another right angled triangle. So this angle here is also complementary to angle ADB. So we have got two equal angles we can see down there. Now I want to exploit those equal angles by dropping a perpendicular from E to DC, because that would give me a pair of similar triangles. Okay, I'll call this point here F. And so I can say that ABD will be similar to this new triangle DFE. And ABD is a 3-4-5 triangle in terms of ratios. So DFE will also be a 3-4-5 triangle. And since BD is the shorter leg, it corresponds to EF being the shorter leg. So 3-4-5 triangle with hypotenuse 15 would be 9, 12, 15. Now, another thing that this construction does is that it gives me a pair of parallel lines. So I get another similar triangle, or rather another pair of similar triangles, CEF and CAB. So CF over CB, sorry, that looks like an L. CF over CB is equal to EF over AB, which is 9 over 144, which is 1 over 16. So if we solve this, that means that CF to FB is in the ratio 1:15, FB is 120, so CF is equal to 8. And so this implies that CD is 8 plus 12 equals to 20. Finally, for this set is question 15. And question 15 is probably the most difficult one so far, mainly because it involves a few different small ideas which are quite difficult to piece together. So in question 15, fx is a quadratic function with a and b being positive. And gx is absolute value of fx minus 2022. Given that gx equals to 0 has exactly 3 roots, determine the minimum possible value of b over 2022 plus c plus 9b over a. There's no way that makes any sense right now. So if that does not make any sense, we can just put it aside first and instead focus on what's the significance of exactly 3 roots, because that's the only piece of information that we have. Now gx equals to 0, gx is an auxiliary function in terms of fx. Right? So it tells you that fx minus 2022, or rather the absolute value of fx minus 2022 equals to 0 has 3 roots. This means that fx is either going to be 2022 or negative 2022 for those roots. So cumulatively, these have 3 roots. Now, obviously, these roots cannot overlap with each other. So for a normal quadratic, it is supposed to give you 2 roots each. Now that did not happen. So it means one of them is 2 roots, one of them has 1 root. You cannot have 3 roots belonging to the same equation. So if one of them has 2 roots and the other has 1 root, the one with the 1 root is going to be the minimum value of the function, since a is positive, so the graph is going to look like this. And so there will be a minimum value that only gets hit once, and there will be some other values which is hit twice. And this must be how it happened. Well, obviously, 2022 cannot be the minimum, and negative 2022 must be the one that is the minimum among these two, because both of these are values of fx, so the smaller one must be the minimum value. So this implies that negative 2022 is the minimum value, and honestly that's all we can say. Right? That's the only implication of gx equals to 0 has exactly 3 roots. But although that is the only implication, I can use the fact that there is one real root to say that fx plus 2022 equals to 0 has only one root, and let's write that using the coefficients a and b now. Constant coefficient will be 2022 plus c. This has only one root, so it means the discriminant has to be equal to 0, which is nice because it is not an inequality, it's an equality. So b squared minus 4a 2022 plus c equals to 0. You might be starting to smell a rat here because there is 2022 plus c as well in there. And indeed, if you rearrange this, you can write b over 2022 plus c equals to 4a over b. So let's go back into the main problem, which is finding the minimum value of this expression, and substitute b over 2022 plus c for 4a over b. So my task now is to minimize 4a over b plus 9b over a. This can be done using the AMGM inequality. Right? This plus this, both are positive, so we don't have to worry about dividing by 0, we don't have to worry about negatives. So this is greater than or equals to 2 times of the geometric mean. I can place this indirectly because they're all positive, but more importantly, it is nice to place them in because a over b and b over a will cancel out. So the minimum value is 12. This would happen when the two are exactly the same, which can certainly happen if a over b is in the ratio 3:2 And there's no reason why that cannot happen. So we know that this is actually going to be attainable. Right, and on that note, we shall conclude the video here. Once again, please subscribe if you haven't already. Feel free to leave any questions or comments below. And do look out for the last two videos where we'll go through the last 10 problems, which are also the most difficult 10 problems as a whole. So thanks for watching and see you again soon.